All right, everyone. This is a quiz 5 review practice. Right. Question 1A. Find the sum of the first 6 terms of a geometric series, given the first term is 2 and the fourth term it's 128. So remember that the formula for the sum is S of an nth equals your first term, 1 minus your ratio raised to the nth term over 1 minus your ratio. Okay, so now we are given the information that we want to find the sum of the 6 terms, so that's our nth, it's 6. We also given that the first term it's 2. We don't have a second term, we don't have a third term. Our fourth term will be 128. Okay. So we do know that our first term is 2. We are looking for our ratio. All right. So since we know our first term, we know that our ratio, we're going to multiply it 1 time, second time, and the third time. Okay. So always remember that when you do the ratio, it is going to be 1 less than the last term given. So since we are given the fourth term, our r, which is our ratio, is going to be to a third power. So 2 is our first term. We got 3 r's, 1, 2, 3. So that's going to be r to a cube power. Has to equal 128. Okay. So of course now we're just going to divide both sides by 2 because we're solving for r. R cubed, it's going to equal 64. And now to get rid of the cube root, we're going to cube both sides. Okay. Just remember that when you're putting it in the calculator, you cannot put 64 cubed. You have to rewrite it as 64 to the 1/3, as 1 is our exponent and 3 is our index. Okay. So when you do that, you're going to get 4. All right. So our ratio, it's 4. So now we are able to, let me move this down a little bit. Now we are able to, we have all the values possible. Now we are able to plug it into our sum. So this is going to be sum. Sub 6, right, equals our first term, it's 2 times 1 minus our ratio, it's 6 raised to, our ratio, it's 4 raised to 6 power, right? All this over 1 minus your ratio, which is 4. All right, plugging it in all into the calculator, we are going to get 2,730. Okay, so that's our final answer, and it's answer B. All right, moving on to the next question, 1B. Give the geometric series 7, 21, 63, and 189. What is the sum of the first 10 numbers in the series? Okay, so again, we are given our n, which is the first 10 numbers, which is 10. That's what we're calculating. We know that our first term is going to be 7. And looking at 7, 21, 63, and 189, I can tell that are multiplied by 3. Okay. So I know that my ratio is going to be 3. Now again, plugging it into our sum. Okay, we are doing sum of sub n, which is 10, equals our first term, which is 7 times 1 minus our ratio is 3. It is raised to the nth power, which is 10. And all this over 1 minus your ratio, which is 3 again. I would keep this part right here in a calculator in a parentheses, just to make sure when you're dividing by the sum of 1 minus 3. And you should get 206,668. Okay, so 206, 668. All right. All right, in example 2a, we are solving for x. X is in our exponent right here. All right, so to solve for x, I got to get rid of everything around it. So first, I'm going to get rid of my 2, move it to the other side. So divide both sides by 2, because there is a multiplication, so the opposite operation would be division. These 2 is going to cancel out. 24 divided by 2 gives me 12. E to the x plus 1. Now we know that inverse of e is ln, so to undo the operation, I'm going to put a ln here, right? E and ln will cancel out. On the left side, I'm going to have a ln of 12, and now my exponent drops down to x plus 1, and all I have to do is move the 1 to the other side, okay? So that's ln of 12 minus 1 equals x, right? Now just remember that this negative 1 does not belong to the parentheses, okay? We ln the 12, not the negative 1. All right? Example 2b, same thing. We're solving for x. So I do need my ln to be by itself. So I'm going to move the 2. The 2 is an addition, so the opposite operation will be subtraction. So I'm going to subtract 2 from both sides. Okay, these cancel out, which leaves me with ln of x minus 3 on your left. And 14 minus 2 is 12. Right? Now my ln is separated. I'm going to do the inverse operation, which is e, to get rid of this ln. E on both sides, whatever you do on the left, you do on the right. Ln and e are going to cancel each other's out. X minus 3 stays on the left, and I have e to the 12th power on the right. And now to solve for x, all I have to do is move the 3. So I'm going to add the 3, because right now 3 is subtracting. I'm going to add the 3 to both sides. 3's cancel out. X equals e to the 12 plus 3. Now you can put it all in a calculator, and you should get x equals 162758. Okay? And that is your final answer. Now for question 3, again we're solving for x. Just to remind you the property that if you have the same number or log or ln on each side of the equal sign, you're able to cancel them out. Okay? So I got 27 and I got 81. So I'm going to make them the same on both sides. So I'm going to try to convert 27 and 81 to the same common constant, and that way I can cancel them out. So I know that 27 and 81 have 3 in common. Okay, so I can convert the left side to a 3 raised to a 3rd power, will give me 27. And then, of course, the exponent stays as x plus 6. And on the right side, 81, I can convert it into 3 raised to the 4th power, gives me 81. Okay, so all I'm doing is substituting 27 into 3 raised to the 3rd power, which is the same thing as 27, and 81 as a 3 raised to the 4th power. And of course, I still have 3x plus 2 as my exponent. Okay, now these 3's on both sides of the equation are going to drop and cancel out. So my exponent drops down to 3 times x plus 6 on the left and 4 times x plus 2 on the right. So of course I have a 3 and a 4 in the front of the parentheses, which means I have to distribute it. So I'm going to distribute 3 and distribute the 6. This is going to be 3x plus 18. And then on the right side, I got to do the same thing. Distribute the 4. 4 times 3 is 12x. And distribute the 4 again to the 2, which is 8. Now I'm just combining like terms. So I am going to move everything to the left when it comes to x. So combine x's, I'm going to move 12x, which means I'm going to subtract it, okay, for them to be able to cancel out. 3x minus 12x is going to give me negative 9x plus 18 equals 8. And now I'm going to move 18, subtract it from the left to the right. I'm going to get negative 9x equals negative 10. I'm going to divide both sides by negative 9 to solve for x. Okay, so x equals 10 over 9. Because remember, we have two negatives here, which are going to cancel each other's out. Okay, so 10 over 9 is your final answer. Now here, for example, 3b, again, I have logs. Again, if they are logs of the same base, exactly the same on each side of the equal sign, and I don't have any additional stuff around it, these logs can cancel each other's out according to the property. So what I have is the insides of the log was x minus 4 equals 2 minus 3x. And again, the same thing. I'm going to move my x's with x's and constants with constant. Okay, so I'm going to add 3x to the right side, add 3x to the left. The x's will cancel out. I get 4x on the left minus 4 equals 2. Now add 4 from the left to the right. 4x equals 6. And to solve for x, of course, I'm going to divide both sides by 4. X will equal, I'm going to simplify it. 6 divides by 2 gives me 3. 4 divides by 2 gives me 2. So that's 3 over 2. Okay? All right, so it's log base 1.055 of 1.90 will now equal to a time. Okay? So of course, we're going to use the exchange base formula to calculate this part in a calculator. So we're going to have a log of 1.90 divided by a log of 1.055 equals t. So t, in this case, will equal 12 years. Okay? All right. Question 6. It says if d equals c times 10 raised to the b times x, where d and c and x are positive, solving for b, which expression is equal to b. Okay, so all we have to do is convert it into what b equals. Okay, so I have d equals c times 10 raised to a b times x. So I want to solve for b. All right, so that means that it is an exponential function again. So we do have to convert it into a log. So first, before I can do that, I have to move all the things around. So I'm going to divide both sides by c to get rid of this c. So my exponent can be by itself. All right. So on the left, I get d over c now equals to 10 raised to b times x. Again, I am solving for b. So I am ready, now my exponent is by itself, I am ready to turn it into a log, okay? So log, it's going to be a base 10, all right, of what's on the other side, which is d over c, now equals to my exponent, which is b times x, all right? Now again, I'm solving for b, so the last thing I have to do is get rid of the x. I'm going to divide both sides by x, okay? So my final answer is log base 10 of d over c divided by x equals b. So that would be answer B. Nope, answer, I apologize. Maybe answer A. Okay. All right, guys. Let's go back to question 5 that I skipped. I apologize for that because I was writing too big. So here it says the value of the computer depreciates over time. Molly purchased a new MacBook Pro in August of 2019. The value of V, the value is represented by V of her computer after T years can be modeled by the equation right here. All right. If you want to know the specific value of the car after T years, how could you, it should be after the computer. After 2 years, how could you rewrite the equation? So again, we're solving for V. So our equation is T equals log of 0.34 of $2,399 of a value. Okay, so again, we got to convert it from a log to exponential, right? Because we're solving for v right here, all right? So our we don't have any additional stuff around the log to move, so we're just going to go straight to it. So our base is 0.34. We're going to raise it to what's on the other side, which is t, and that's going to equal the 2,399v. Okay, now again, we are solving for v, so that means the last thing I got to do is divide both sides by 2,399. Okay, so now my v will equal 0.34 raised to a t divided by 2,399. Okay, so that should be answer B. All right, now let's go back to question 7. Right, it says the cost in $1 of copying paper is given by the function, okay, where P is the amount of paper and C stands for cost. Which function is equivalent to the given situation? So again, we're solving for P, okay, as the amount of paper. So my function is C equals 0.2 P cubed plus 1. All right, so this is what we're solving for, P. So to be able to do that, I got to move all this stuff out of the way. So we're going to subtract before we divide. So I'm going to subtract -1 and move the -1 out of the way first. So C minus 1 now equals 0.2 P cubed, okay? Now again, if I'm solving for P, what else do I have hanging in here? I have 0.2. So again, this is a multiplication here. So I'm going to divide, which is the opposite operation. All right, I'm going to divide both sides by 0.2. So now I have C minus 1 divided by 0.2 on the left, and then P cubed. And of course, I have to get rid of that cube. So to be able to do that, I got to cube both sides. Cube root, okay? Cube root both sides, so these can cancel each other's out. Now P will equal cube root of C minus 1 divided by 0.2 cube root, okay? So that should be answer A. All right. All right, moving on to example 8. Let's see if I can move it over. All right. We asked to simplify it. So again, remember the property. If the log of the base and the base of the exponent are the same, they can cancel each other's out. So log 6 of 216, we're going to convert the 216 to have the base of the exponent of 6. So I can turn log base 6 of 6, so these two can match, okay? That way they're able to cancel out. Now 6 to what power would give me 216? It would be cubed, okay? Now, on the second part, I'm just going to rewrite it here first so I can see both of them cancel each other's out, okay? Now, I can tell that right here, 4, so exponent base and the base of the log are the same, 4 and a 4. So these can cancel each other's out, which means the 11 will drop. Okay, now I converted 6 and a 6 here, so these can cancel each other's out, which drops to 3. And of course, we're adding in between. So 3 plus 11 equals 14. Okay, now question 9, we're expanding the log. So remember, when you do that, you got to simplify it first. Numbers with numbers, A's with A's, B's with B's, Z's with Z's. Whatever variable you can only simplify it with the same variable if it's there either on the bottom or on top. So, having said that, I see that 2 and 6 can simplify to 1 and 3. All right, so I'm going to rewrite it as I go. So I got log 3. So I simplified 2 and 6 to 1 and 3 now, okay? Now I have 1A on the top and 7 A's on the bottom. If I take 1A away, there's going to be no more A on the top, but there's going to be 1 less A on the bottom, right? Because remember that we do A to the first power over A to the 7th. When we have the same base and different exponents, we're going to subtract the exponents, 1 minus 7, which gives you -6. And -6 indicates this negative that it stays on the bottom, okay? And then lastly, we have b to the third power on the top and b to the second power on the bottom. Again, if I take 2 away and I have more on the top, and I take 2 away, I'm going to have 1 b left on the top and no b's left on the bottom. Okay, I just want to write it out so you can guys visually see it, because again, this is b to the cube over b to the second power. So that's b3 minus 2, okay, which gives you b to the first power. Since it's positive, it's going to go on the top. Okay, so now we're going to rewrite it, right, nicely, because the ones, we don't have to write the ones. So this is going to be log cubed of b on the top 3 times a to the 6th power on the bottom. All right, now I am going to expand it. Okay, so that means how many logs am I having? 1, 2, 3. Because remember, it's a log of every single item that's in that parentheses. So I have a log 3 of b, then I have a log 3 of 3, and I have a log 3 of a to the 6th. Okay, now the top log, it's positive. The 2 bottom logs are going to be negative. So negative log 3 of 3 and negative log a of 6. And then lastly, of course, we can't forget that this 6 is exponent, has to go to the front. Okay, and make it a coefficient. So log 3 of b minus log 3 of 3 minus 6 log 3 of a. It's my final answer. All right. All right. Question. Let me see. All right. Question 10. Okay. So we are condensing. So we're doing the opposite operation. So we're going to put it back together as a 1 log of. All right. So let's see. First, we have to rewrite and make sure we move our constant, our coefficient into the front. As an exponent. I'm sorry. So we're moving it as an exponent. So I'm going to rewrite it. So I'm going to rewrite it as a log of base 5 of a now to the second power plus log of base 5 to b to a third power plus log of base 5 a to the 7th power. Okay. Now, since all the logs are the same base, I can make it into a 1 log of 5. Okay. Now, all of these, other than the front one, are positive. Okay. So the negative log, which is this one right here, the negative log of 5 of a squared, it's going to go on the bottom. Okay, so a squared goes in the bottom because it's negative, right? Negative indicates it's going to go on the bottom of the fraction. Now, log of b cubed and a 7, it's going to go on the top because they're both positive. Now, am I done here? No, I have to simplify the a's. Okay, so again, I get a to the 7 and a to the second power. If I take 2 away, I get 5 left and then nothing here. Okay, so I can rewrite this log as log base 5 of, okay, and now I don't have anything more on the bottom, right? So it's just going to be b cubed times a to the 5th power. Okay, and this is my final answer. Let me move that a little bit. So you can guys see. All right. So question 11 says select 2 statements that are true about the function of log base 2 of x minus 1. All right. So again, the first thing that I do is I make sure that I draw where my asymptote is. All right, where the flat side is. So obviously log, which means that the asymptote is going to be vertical, going through an x-axis. Okay, and I can also indicate that my asymptote is at 1. All right, so first one, the domain is negative infinity to positive infinity, which means all real numbers. That is not true because I cannot go left to right freely. Why? Because I have my asymptote here. Okay, so that would not work. All right. Now, second B, as x approaches 1, f of x, which is my function, approaches negative infinity. So let's see. As x approaches 1, all right, so we're going this way. We're approaching 1. Now my function travels toward negative infinity. That is correct. Okay. All right. C, my asymptote is at y equals 1. It is not correct because asymptote does not cross y-axis. It crosses x-axis. Okay. So that is not correct. D, the range is all real numbers. That is correct because range is our y-axis and it does go up and down freely. So this is a correct statement. All right. And let's just go through it for E and F, even though that we already found our two correct answers. Here it says f of x is positive. Remember, f of x means function is positive for all x greater than 0. So let's see. We don't have function in this place between 0 and 1, so this could not be true. Okay? And then the last one, f, as x increases, which means going toward positive infinity, right? Because this is where the x's are getting greater and greater and greater in this direction. Okay? F of x, which is my function, approaches but never reaches 5. So it's saying on the right side right here, when there's a positive infinity, my function is approaching 5. Does it kind of look like it's approaching 5? Yes, it does look like it. But again, function keeps going. There is no asymptote that is horizontal. So that could not be true. Okay? All right. And then in question 12, which statement describes the graph? Select again two that apply. So right here, I'm going to make my point first, which is at -2 and 3. So -2 and 3. So here it says as x, the first one, it says as x approaches negative infinity, f of x approaches infinity. So again, as x approaches negative infinity, that means when x is going in this direction, all right, my function, it approaches infinity, okay, which means it's going up. That is not correct. My function is going down, all right? B, the interval of the increase, it's negative infinity to -2. So we are reading it left to right. We are going from left to right. Let me get a different color. We are going from left to right, all right? And my function stops. So reading it from here to here, this is where my function is traveling through. From negative infinity, it is increasing to an x value of -2. So that is a correct statement, because remember, this is x-axis. That's why we're reading it off. C states that x approaches positive infinity, okay? When x approaches positive infinity, my function approaches 3. So again, as we're going this way, my function stops at 3. So this is correct, all right? And then D, the domain is y, it's less than -2. Right there, domain does not represent y, it's x-axis. So this could not be correct. And then the last one, over the interval of -5 and -2. So remember, we're looking at the x-axis, -5 and -2. Okay, in this range, it says that our values of the function are negative. That is not correct. They are above 0. All right. There's nothing here to state that they are negative. All right. So this could not be correct either. All right, and the last two. All right, question 13, it says, what is the inverse of y equals 3 raised to the x plus 2? Just a reminder, when you guys finding an inverse, you're switching x and a y. So I'm going to switch x and a y here. So now x equals 3y plus 2. Now this is an exponential function. All right, so we know we're going to convert it into the log. Again, we don't have anything around it that we have to move or divide or subtract or add. So we're going to simply convert it into a log. So this is going to be a log of my base of 3. And now again, remember that these change places, right? So x will come in and y plus 2 will come out, okay? Now to solve for y, we have to move -2 to the other side, okay? So my log now of the base 3 of x minus 2 will equal y. Now please pay attention that when you're moving this -2, okay, it does not belong to that x inside the parentheses that belongs to the log, okay? It stays on the outside, all right? So this is your answer. So it should be answer A, all right? And then the last one right here, question 14, says the population of the city in Italy was approximately 66,000 in 2017. Okay, the population has decreased, which means we're going to have a 1 minus every year by a rate of 1.5%. What would be the population of the city now? Okay, so we're asking for the final value. So just a reminder, it's a final value of an initial value, 1 minus the rate raised to time. Okay, so this is pretty straightforward. We are given the value that we have right now, which is 66,000, 1 minus our rate, which we're going to convert into a decimal divided by 100, which is 0.015. And we also know the time. What is the time here? The time says in 2017 till now. So 2017, 2023, which is 6 years. Okay. All right. Now, if you put it all into the calculator, you guys should get 60,278. All right, which is answer